Corporation with Chris Stathopoulos. All right, I got his name right. That's a good start. He's here to talk to you today about primary fault locating. Thank you, Chris.
All right, thank you. Good morning, guys. Again, my name is Chris. We're going to talk about primary fault locating. Vaughn Corporation, we're a manufacturer located in Birmingham, Alabama. We've been around for about 50 years. Our main focus has been basically cable testing, high pot testing, and primary fault locating. We also do some VLF testing. Again, been around for over 50 years, manufactured product in the US. That XF series primary fault locator, that's the #1 selling fault locator in the industry. Some of the things about our company, best customer service and parts availability. We offer training on any one of our tools from the day you buy it, any time down the road. We offer free training at any point in time for any piece of equipment we've ever sold to a customer. Another thing we offer is that some of the other companies don't provide 24-hour technical assistance. So if anybody buys any of our product, they're using it, they're in the middle of a fault, it's 2 a.m. and they got a problem with it, they call one of our techs, and it's a 24-hour number that we will provide at any point in time. These are some of the industries that we sell to. Substation, wind farm, power plants. And here is our primary fault locator. We call that our portable unit. What we have with our fault locating equipment is we use arc reflection. That's probably been around for about the last 15 years or so. And the way arc reflection works when you're fault locating, you guys familiar with a fault locator and a thumper? Basically all it is just a large capacitor. Charges up the voltage and then it discharges it. When it discharges it, that's where you're listening for your fault, to pinpoint exactly where that bad spot is on your cable. With arc reflection, what we're going to do is we're actually going to test that cable. We're going to find out a span of cable, whether it's 200 feet long or 3 miles long. We're going to be able to determine how long that piece of cable is, where the end of the cable is. Once we apply voltage to it and get that capacitor to discharge, you have a bad spot in that cable, it's going to arc across that gap. Once it arcs across that gap and discharges, our radar or our arc reflection method is going to tell us where that bad spot is in the cable. So now we have a 2-mile span of cable at 1,732 feet, that's where the bad spot is. So what do? At that point, you walk off, stand at about 1,730 feet, you charge up your thumper, and then you get it to discharge, and then that's where you're listening for it. So what's changed in the past 30 or 40 years in the industry is we had those suitcase-style thumpers that people used to use in the past. Then they've gone to a thumper like this with radar, so we've just basically cut down the amount of outage times, tenfold to what you're sending to your customer. The amount of time that, I would hear stories that people would go out and locate a fault for a week. It's just a hard to find fault, they couldn't find it. Now we're taking that and we're cutting that down, and most of the faults, people are using our equipment. Majority of them you're going to find in about 15 to 20 minutes. You're always going to find those challenging ones that you're going to run into, but having a radar enables you to do that. When you're hooking up our equipment, you've got 3 connections that we're going to make. You can use a load break elbow. That's going to plug right into our high voltage lead, and that's going to go right on the conductor that we're going to test. This green cable right there, that's going to go on the neutral. The importance of that cable, that connection, is that's going to go on the neutral of cable that we're going to test. That's going to be our return path to the machine. Because what happens is when you're analyzing your cable, you're going to send a pulse down that center conductor. It's going to look for an impedance change, and it's going to come back to the machine, and it's going to travel on the neutral. So as long as our neutral is intact and we have a good neutral, then we're going to be able to get that accurate distance. Okay. So this is a typical, what we would call a radar trace. Once you've made your connection and you've hooked everything up, you're going to turn the machine on. We haven't done anything. Once we do that, we're going to look here. It's always telling us what's happening. Right marker at open or end. And then you see that up spike at about halfway down. That's the end of our cable. So the machine right now is telling us the end of our cable is 796 feet away. Now, as an operator, it's up to you to verify that. Now, typically when you're out there looking for a fault, you typically should know approximately how long your cable is. Now, if you don't, that's okay too, because what we would do, I keep hitting that button there, we can actually go to the other end on an isolated piece of cable. What would happen if we were to have a piece of cable isolated and we were to go to the other end and put a ground on it? We're creating basically a dead short, right? If we create a dead short, we're going to take that up, what we call an up spike, and we're going to flip it, and we're going to make it look like a dead short, which means it's going to tell us that that's the end of our cable. Now, let's say our cable was 2,000 feet long, and it tells us right marker at open or end at 796 feet, but you open up your maps, and your map says no. The machine's wrong. The machine doesn't know what it's talking about. I know my cable's 2,000 feet. What that's going to tell me is at 796 feet, something happened. Could be a cable that's blown in two, and if the cable's blown in two, it's saying I can only see up to 796 feet. I can't see past it because our neutral's gone. Or if you have that bare concentric neutral wrapped on the outside of your cable, the cable 35, 40 years old. I don't know if cable's that old out here, but every other utility, every other company I deal with, that's typically what they say, right? You guys are nodding, so yeah, it is. If our neutral's completely gone, that's as far as we can see. So the machine really doesn't know the difference between an open or an end. All it's saying is, that's all I can see. I can only see up to that point. So what you do at this point is if you verify that end or your map says, hey, my map says 800 feet to the end of the cable, we're good. Now, what you're going to do is you're going to push the start button. And when you push that start button, you're going to charge that capacitor up. You can set the voltage to anywhere between 3 all the way up to 25 kV. If you get it to discharge, so on an isolated piece of cable, one of two things is going to happen. It's either going to hold voltage if my cable's good, or it's going to discharge if there's a fault. Once it finds the fault, that's what you're going to see. The machine tells you, right marker at fault. So now we had an 800-foot piece of cable. Now we've gone to 678 feet. And that's where our fault is going to be. So at that point, now we're gonna locate our cable path, because that's one of the most important things to do. I've been out in the field with people, and oh no, I swear this cable runs straight down here. Goes from this transformer to that one. Then you're out there thumping your cable for an hour. We can't hear anything. Get them to locate. Then all of a sudden, you have to be on that cable path. You're going to go out to that almost 700-foot spot, and then we're going to listen. And that's where we're going to be to actually listen to where our fault is. Okay. I showed you that big portable unit that we saw a few slides back. Now this is our newest unit. We call it the SST-15. It does the same thing that big portable unit does. It just has a smaller capacitor in there. So this one here, we can charge up to 15 kV. The other unit can go all the way up to 25 kV. Now, you guys familiar with fault locating at all? Somewhat? Okay, when we talk about fault locating, the perception is the amount of energy, or the amount of voltage is what actually is what you need. The higher the voltage, the louder the thump is going to be. That's not really a true statement. What it really is the amount of energy that's created from that capacitor. And that capacitor, on this one here, can charge up to 830 joules at 15 kV, so that's how much noise it's actually creating. That other portable unit, we can put out 1,560 joules. So these two machines are very similar, but it's how much guts can you fit in a box this big, how much guts can you fit in a box that big, you know? It's like using your pickup truck or you have a dump truck, how much more you can fit in there. One of the other features that the small unit has built in is for sectionalizing. So up here, we see the end of our cable is 1,000 feet. Down here we see it's the same cable we're testing. That's also at 1,000 feet. All this in here, all those, we call those impedance changes, right? That's what we had on the other cable we tested. It was just a straight line. This one here, those are all transformers. So now we can use a small unit like that. Now, where we would supply something like this would be to your first response teams. You have an outage in the middle of the night, you got a loop system. I've got 8 transformers in my loop. I don't know which section of cable is bad. To cut down on the amount of time that we're going from transformer to transformer all the way down, what you do is you hook up, you send that pulse down, you apply voltage to it, and it tells you where's my fault. It's between my second and third, my fourth and my fifth, wherever that fault is. So what you do at that point to sectionalize, I'm not worried about finding a fault at 2 o'clock in the morning. I'm worried about getting the power back on. So what you can do is determine which section is bad, shows you where the fault is, backfeed it, get everybody back on, and then you can, locate it tomorrow. Yes. If there's a splice on the cable. Yes. Yeah. This isn't a good picture of it. If you go back a few, okay. This is what we call, this is the radar trace, right? In here, you would see a little S laid on its side. That would indicate that's what a splice is. So what this machine will pick up would be the end of your cable, the fault, a splice, or transformers. So, and what you would do is if you said, okay, this really isn't a splice, but there is a change there, so let's just say that was the splice. This right here is my 0 point. This right here is wherever the fault is. If that was a splice right there, you could actually control. You hit that right marker button at the top, you move that marker to there, and it would say, okay, at 341 feet, that's where my splice is. Change impedance, a change in the impedance. So look at it this way. You have, I've got a couple minutes left. You have a piece of cable, okay? We're hooked up in one transformer. We've got our feed through, and we've got our elbow plugged in, right? The other end is, the cable's isolated. Where it's isolated, we have it stood off on a parking stand. Everywhere in between, when you see a straight line, my cable's completely intact. Once we throw a splice in that cable, what happens? Well, the cable was broken at some point. You had to put something in there. You had to splice it. What that splice is, here's my conductor and my neutral. Now there's a break in it. So that's what the machine is going to identify. Once you have that break, it's an impedance change, and the software in it notifies that. I think that was the end of my slides there. Okay. This is just a picture of some of the training that we do. Anybody that buys equipment from us will do classroom training like this, and then we go out in the field and do training. We've got companies that will buy our equipment, we'll come in and train them. A year from now, we got 5 new guys. They don't know how the equipment works. We come in and we do all of that for no cost. Okay. That's all I have. Any other questions? Okay. Appreciate your time, guys.
All right.
Thank
Thank
you.
you, Chris Stathopoulos.